All right, hello everyone. I'm here. My name is Pavel Feldman. I'm here to talk about Chrome DevTools. And yeah, right. I was asked if I know a feature in Inspector exists or I am familiar with it. Yes, in fact, I am. So DevTools is we have a team at Google that works in St. Petersburg that works on Chrome DevTools. And before I go into the content of the presentation, I'll say a few words about the history of DevTools and how we ended up there. And why we are here, actually. So it all started with a team of Googlers joining the effort at WebKit and Chromium back in 2009. Please raise your hand if you have been in WebKit in 2009. All right, some hands, good. Yeah, so we joined WebKit, and the product was called Web Inspector back then, and it basically was, in fact, the support in Chromium was 2 panels. It was elements and resources, where we showed the network information, and some console. And that worked in an interesting manner. It was a web app. And that web app was basically holding pointers to live objects from the inspected page. So we were passing document into inspector as an object. We were wrapping it into a quarantine object so that we don't leak or don't meet some security issue. We anyways hit all of those problems. But then it was just inspecting it from JavaScript. And when we needed to find out what are the properties of DOM nodes, we were asking DOM node using web-facing API, hey, what's your attributes? What are your children? When we were inspecting styles, we were saying, all right, what are the style properties? And some of the methods that were introduced solely for the sake of inspector are still there in the platform, like this window get matched CSS rules. Nobody needs it. Inspector needed it. So they were there. We no longer need them, but they stuck in the platform. And why Blink? Why we're in Blink? Well, Blink is our runtime. And when you're inspecting a runtime, you want to be closer to it. So you want to be in this runtime source space. So 90% of Chrome DevTools code is actually Blink code. And you might ask why our front end, which is a web app, is in Blink. Well, the answer there is simple, because we like being able to type more than 80 characters in a line. And our only other options was Chromium. So the agenda for today is for me to share with you what we are busy with, to outline the major areas for us where development takes place. And it's mobile, performance, and debugging. No surprise. And for each of them, the structure of the talk is going to be, I'll share with you where we are and what we are dealing with currently, what our challenges are, and I'll specifically outline in red where we need your help as a Blink community, as Blink feature owners. So again, it's going to be mobile, performance, and debugging. And when we are talking about our priorities as DevTools, they are aligned but not necessarily matched with the ones of Blink. So when we are saying mobile, it's not that we want platform to scale well and work well on mobile. It's that we want developers to be able to develop for mobile. Same goes for performance. The Blink's priorities are to make things run fast, to deliver 60 FIPS. In our priorities, it's to make web developers achieve those 50 FIPS and not screw things as they go with the platform. So the first area for us is mobile, and mobile for DevTools is basically 2 things. It's emulation and remote debugging. And those are different scenarios that are solving different problems. Emulation is primarily for the ones that are designing and developing their web apps for multiple screens. And we don't want them to leave their development environment for them. Yes, world goes mobile. No, developers are still using keyboard, and we want to please them. And they don't necessarily have a large variety of devices that their content runs on. So they need to be able to emulate a lot of environments, a lot of modes, without leaving their desktop environment. And then it's remote debugging. And remote debugging is where you are as close to physical hardware as possible. So you can remote debug your device, you get the adequate performance characteristics out of it. And in addition to that, it's an ideal environment to emulate the feature set that there is on the platform, because devices vary, their characteristics vary, features available to them vary from one to one. So those are 2 areas. And as promised. So where we are on those. The emulation, we can emulate your screen resolution, but screen resolution is not enough. Devices have high DPI. High DPI is a different world. We need to be able to emulate the device scale factor. That's how it's called in Blink, or device pixel ratio. That's what web developers call it. And then there's a viewport. And you know what? Things work differently with it or without viewport. And by the latest moment, viewport was what? Behind the compile time flag? It was hard to emulate something that is behind the compile time flag. Then there's text auto size that actually changes how you see the page a lot. Then it's touch and gestures, and that's where we emulate the complete sequence of events as they would happen on the device if you touch the glass, basically. Then there's the user agent, because currently page owners are sending different content for different types of devices and some sensors. So I have a question to you. I can demo those things, or I can be showing slides. Which one do you prefer? Demos are funnier, slides are quicker. What?
I like fine.
Fine, okay, fine. Okay, so emulation. Switching to Canary. Can you see it okay? It's a Wikipedia page. I open the DevTools, emulation drawer, Nexus 5, hit emulate. I have a new viewport, and I can grab things here. The content is still from the desktop version of the page. I need to reload for Wikipedia site to send me the proper content. Okay, here it is. And I can scale things, span things, and I can obviously inspect things. And that's our emulation story. And you can see this emulation panel that has screen properties and user agent and sensors. And for example, let me go to the HTML rocks page. So my my screen is high DPI, and there's a 2x because the image set is serving the high resolution version of the image. So what I do is I say emulate screen. My device pixel ratio is 1. My screen resolution is 800. And I am getting served and displayed the low DPI version of this image. And that is handy, because on the small screen, like 13-inch MacBook Air, where our developers are, you can emulate like 2800 pixels, and we will scale things down. And you can emulate high DPI values here as well. So that's what emulation for us means. We have a list of devices where we know the characteristics of screens for and other properties, user agents. So you just pick a device, you reload a page, boom, you are developing against that device. So right, so that emulation. So what's next for us on the emulation front? The next is to further explore those features and to dive into the responsive design mode. I've shown you how I was changing the resolution. That's not how developers would like it to be. They want to be able to go from within ranges of resolutions to test their media queries, because there's a great variety of devices, great variety of resolutions there. So we are going into the sort of a UX war against the good, or for the good experience there. Then the other thing for us that is very important for us is emulating platform characteristics and platform feature sets. Because varying from device to device, or from browser to browser, or from vendor to vendor, is going to be different feature sets. Not all of the browsers support like WebGL and mobile. So our users want to emulate that. And the first feature in that kind of a list is a network, where we absolutely need to start emulating offline mode, or spotty connectivity, or traffic shaping. So offline is something that we're currently working on. And as for platform features, that's where I am making a call for your contribution and your help as Blink feature owners. If you are working on something, be it input latency, or layout, or whatever, or say some animations, you need to make sure that your feature is available there in desktop. We want to be able to enable or disable it, especially if it differs on mobile versus desktop. If it differs from Blink to non-Blink. If it is behind a compile time flag, or we can't survive changing it in runtime for some reason, it is going to be bad for our users, for web developers. So please use runtime label features, web settings, anything where we can toggle it on. And developers will survive reload. That's the reality for them because of the UA sniffing primarily, because you have a different content based on your UA string. So it's a common thing to pick a new device and reload. For remote debugging is where we are. We are everywhere. We're everywhere Blink or content is running. It includes Chrome for Android, web views, common shells, everything. And you can debug things using not only DevTools, but other frontends, other clients, such as telemetry, WebDriver for automation, extensions, APIs. So the feature set on remote debugging is everything you have on desktop. So you plug in your phone, you get everything you get on Chrome for desktop, for regular one. And in addition to that, we have screencast and port forwarding so that you didn't have to touch your device. So we want you to plug it in, place it on your desk, and then switch to desktop and continue your debugging and hunting performance or other issues. And yeah, well, demo time. So there's a Chrome Inspect page, the page where everything starts, and I'm connecting my phone to my computer, unlocking it. So what you can see on this screen is, you don't see anything on this screen. Let me zoom in a bit. And zooming doesn't work for sharing. All right, so let me zoom it like that. All right, you can see something. All right, so there's a couple of browsers because I have Chrome Beta installed on my phone, and there's a Chrome, and there's a web view for Fiddly, and all of those are targets I can inspect. So what I do is I pick any page, like a Wikipedia one, and I hit inspect. And what it does, it fetches a front end for me. My tab isn't active. I need to be showing it, displaying it for the screencast to work. And here you go. So it transmits the picture and orientation from my phone to the screencast. And many things would work here. Gestures would work, so I can scroll things, and even keyboard would work, so I can select, focus, and type something in. And of course, all the inspection, everything that you are used to while using developer tools is working here as well. So that's the remote debugging, and it works for everything, for web views, for any remote target. So what's next for us in remote debugging? Well, it turned out that it is very hard to make web developers use actual hardware. And we want them to get hardware early in the game, because for like gaming development, for web app development, it's absolutely critical to have that experience, to have that running. So we are working on improving this basically workflow that you have seen of plugging a phone and going to a page, via better automation, better connectivity, better everything, so that it was very easy to attach to a phone, be it local or remote or whatever. And we are not calling to any of the help here. All we need from you is trying it out, seeing if it works for you, and basically getting your feedback on that. So that's our mobile, and that's where we are. To recap, what we want for mobile is emulation and runtime-enabled features to be there all over the place. And the next one is performance and memory. And yeah, and again, performance is different for us, for web developers than Blink owners. And this whole sort of story of investigating performance issues is different for web developers. Like Nat was sharing a story about tracing and about the ways we are trying to balance between layers and impulse side painting, and we're experimenting there. Things go to GPU. So there's a lot of detail that is necessary to assess performance. At the same time, not all of these details are valuable to the web developers because they are randomly changing. They are not conservative, and not always we want to expose that to the user. Another differentiating factor from the platform performance is actionability. Everything we reveal in DevTools needs to be actionable by the user. We don't want to tease user with showing some latency that the user or web developer cannot affect. So there are certain requirements and simplicity, of course, in comparison to say tracing, that are being put on our system. So where we are on a sub-millisecond rate for sampling in V8, and we needed to go there because of the 60 hertz thing. With 60 FIPS, you have 16 milliseconds per frame. You have 7 milliseconds for client JavaScript, which means 7 samples if you do it on a millisecond rate. And seven samples doesn't tell you much. It only tells you, okay, you were in that function. That's it. So we wanted to break that. Now it's 10 times more. Basically, it's 100 microseconds. One. Another interesting thing is that the sampling profiling in JavaScript, the traditional way of doing it is aggregate view of top, bottom, heavy, and you have a trees with the costs of methods. Well, when frames get into picture, you have different frames, and different frames are doing different things, and you don't want necessarily to aggregate everything. You are actually interested in outliers, into finding out why this very frame was lagging or was skipped. So for that, we introduced the flame chart that is showing the sort of a tracing view on the sampling. I'll show it in the demo a bit later. Timeline and frame mode there we have introduced long ago, and that was when we teach developers that there is such a thing, a frame, and they have a budget for it. We do some dynamic auditing, so performance needs to be not only deliver figures, but needs to be useful in a sense that you are using a foot gun here. Don't. So we're showing warnings there. If that is not enough, we tell users to go about tracing. We consider them mature enough to look there. And there are some certain memory tools like key profiler and location timeline that we have also considered a performance. So I won't go into demo on this one. So this one is showing the flame chart for JavaScript execution. Oh, I can go into demo for this one. It basically has a waterfall of methods here, and this is a load time, so there's no particular pattern in what's going on here. It's just a bunch of methods being called. Timeline frame mode. Yeah, I'm sure you have seen it, but always good to look at it once again. Oops. All right, so I don't want emulation here. So I'm just recording what I have, and this is this frame budget. Fortunately, I can't zoom with this presentation going. Right, this is not working right. Yeah. All right, so the frame bars at top, the yellow is JavaScript, the green is paint, the purple is layout. That's what has been happening on this page. So I can select a frame and see that, okay, paint was expensive, or scroll was expensive, and the scroll was expensive because there's been a layout, and that layout has been bad because it has been invalidating and forcing layout synchronously within a single JavaScript execution. And we show stacks for that. So that not only have your performance data, you have actionable data on a particular place in your code when you're doing something bad, forcing layout twice. Oops, too much, sorry. Yeah. And then there's performance tools. So performance, the memory tools, and memory is performance. And all the game developers are working with us on the tooling for that. They're fighting allocations, they're fighting memory leaks. For example, this one is showing the allocation tracker. It has a timeline on the top, and this timeline is basically showing allocations over time where JavaScript objects were allocated. There are tiny gray bars and blue bars. So gray is what actually has been allocated. The blue is what has been allocated and has retained by the moment of the user pressing stop. So that's your either cache or a memory leak. And you can see a typical action here. First you allocate and you cache. You basically saturate your caches. Then you do actions with a zero sum. If you do some action repeatedly and you see that it keeps allocating, it means you have a memory leak. You select a range, you see a number of objects there, and the retaining path is below that point to what are the objects that are resulting in this memory leak. All right, so those are our performance tools. And the next thing for us is in this sub-millisecond game, we have lost the trust of developers because we have seen tracing delivering way more accurate timing than timeline did. And the reason for that is that we are capturing stack traces, and it costs. and we are pointing to live objects and it costs, and we want to make traceability, we want to give some good hints, but at the end of the day, you just accumulate the latency and you skew the performance data. So we don't want that. And so that's the kind of the first and most important thing for us. Then we're looking for new experiences UI-wise, and I'll be showing some demos for that. And performance is now rendering performance. It used to be JavaScript performance. Now it's rendering performance, and we need to get data on layers. We need to get data on paint. We need to provide a lot more details into what's going on in the rendering pipeline. Also working on improving our instrumentation for profiler so that we could show the number of calls, and allocation profiler to show actual stacks for allocations. All right, so the new UIs. And one of the new UIs that we have is a tracing-alike view. So you can switch in timeline. You can switch from waterfall, and you don't see how smoothly it zooms, but it is, trust me. So that's sort of an alternative representation of the timeline. And yeah, what else do I have here? Yeah, the sampling one. I can do the same thing and enable an experiment that will do timeline sampling and reload my front end and record a bit and stop. And you would see on a single timeline, you would see timeline events, tracing events, accompanied with the JavaScript sampling profile. So it's a single waterfall where you can infinitely zoom into something that's happening on your page, and you start with native events, and then you go all the way into the handler and all the way into a particular JavaScript function that is handling it. So it's a very convenient way of sort of infinitely diving into what's happening on the page. Sort of timeline on steroids. And then the allocation stacks. So the same allocation tracker, but there's a bottom panel called allocation stack, which points to where in source code what stack has allocated your objects, which is very good. So you know where the object that resulted in a memory leak was allocated in your source code. Sort of invaluable. All right, we have some other experiments such as layers and canvas. Won't be showing that to you. So our challenges. Our challenges on the performance front is that we skew timing, and we have a lot of uninstrumented time. We have a lot of white gaps in what's going on. And that's basically where we need your help. And that's also multiple threads. Timeline was originally created for tracking asynchronous time in page. Page was single-threaded, no longer the case. Paint data, rendering, also no data for to show the user yet. So there's a nice visualization of that. Let me enable one other experiment that is called timeline tracing mode. And I'll do the same action again. Oh, I don't want stacks anymore. Okay, yeah, I don't want stacks anymore. Of course. And I'll reload my thingy. And all right, so I'll scroll again. What you can see here as a part of this experiment is tracing and timeline working side by side. And I can zoom into one of them and see what is there in the other. And you can see that the amount of information that we actually have and that we show to the user is different. And this is not necessarily a bad thing. We don't want to throw all of that amount of information at our user, but at the same time, we've seen scary things there. We've seen things that were instrumented in tracing and simply missing in timeline. So we want to fix that. And the way we fix it is migrating to the tracing instrumentation. So what we're going to do is we're going to ditch all the inspected instrumentation for performance and migrate to trace events that you are probably using. And with that gesture, we would like to make you owners of that instrumentation. So if you own the input latency story or layout story or paint story, we'd like you to identify the traces that you find useful, identify the traces that you are comfortable with sharing with the end user, ideally so that they were actionable, and it was clear what that is about. And then we will take your traces and graduate them into the UI of tools. And as we do that, we will anyways leave the tracing view in place. So there's going to be a timeline for web developers and timeline for you, Blink feature owners, where you would be able to run them side by side, see what costs what, and graduate things to the user's front. And we will publish certain criteria of when you should be graduating your instrumentation to the user. It needs to match one of the categories that we have. We have a category called Other, so everything would work. Then you need to, yeah, ideally it all should be actionable. And it doesn't mean it needs to point to the source code. At least saying you have early in the life cycle of your page, you've done something that might have led to this result. That is already enough, because that's actionable. You can rewind, see how things went there, and fix it. Yeah, what differs us from tracing? We want to provide traceability into live runtime. Tracing would record and replay. We want record, show, traverse, pick a paint event, show a DOM node that was responsible for it. Everything live. And yeah, dynamic auditing is just a modern thing for us. Wherever we can do good advices, we could make good advices, we are trying to, as we are recording performance data. And that's it for our performance. From the last one is debugging, and that's sort of authoring, frameworks, platform, everything. Yeah, well, we have a lot of features covered by debugger. In Blink, things like IndexedDB, file system behind experiment. We've just completed supporting Speedy so that it was on par with HTTP. We have support for some Polymer features, web components, shadow DOM imports. Of course, the live editor, sort of a trademark, edit the sync stack traces. This one shows the Polymer web page with shadow DOM being inspected. And so that's sort of debugging platform features. On the authoring front, authoring is where our users are spending more and more time. We have a workspaces feature that allows read-write access to your file system. And in fact, many DevTools team members are using workspaces to develop Chrome content Blink. It scales to hundreds of thousands of files. It indexes files using trigrams. So it's a convenient development environment. It also supports source maps to map your source base to running to a runtime, which gets increasingly popular in the wild. So what's next on the debugging? And debugging is adding new features, supporting new features like promises, or continuing to work on existing features such as live edit, so that it worked on ARM as well as it does, or as bad as it does on other architectures. And it's supporting your features. Authoring, we will handle ourselves. We just need feedback there. We don't really need sort of a platform support, but platform, we need plenty of support from your side. And that includes expertizing the feature. Like you're going to release web animations or promises. Please share with us what are the typical user scenarios that developers are going to hit. Or you're fighting with the new performance issue. Talk to us, tell us what are the details. We need use cases, like Polymer or web components is a large area and is a complex area. And DevTools frontend is not yet using web components. We would be experts in that and would provide a great UX in debugging it. We're not there yet, so we need sort of your experience there. And we need a debuggability checkbox in the intent to ship, because otherwise we ship things without proper debugging support. Because we ship promises and we don't like it, because we just hide and swallow exceptions if the rejection handler is not there, and our users don't like it. And when we are releasing something new without a good debugging support, it does not look good, doesn't stick to the user. And yeah, that's it to review. It's mobile, performance, and debugging. Everywhere we need your help. Mobile emulation, runtime features everywhere. Features that you were not thinking that need emulation, please think about them. Performance, trace events, getting to own what is getting displayed in DevTools. We don't want to be responsible, or like we don't want to play experts in the areas where we are not, like layout or squashing, I don't know, layers, anything. If you think it makes sense to the user, let's make it available there. Let's hide it behind this simple layer, like simple abstraction layer. Like we don't want to say that there's an impulse height pane. What we do currently is we say there's a CPU and there's a GPU. So we pretend that impulse height pane is GPU. And we sort of isolate user from what is actually happening there. We know it's asynchronous. We know that you have a synchronous budget. That's all you care about. Things like that. And debugging is where we need your expertise, and we need a checkbox in the intent to ship. That's it from my side. Thanks. Questions? No questions? Yeah, some questions. Go ahead. Who goes first?
So you mentioned using runtime flags for the web inspector. How do you toggle runtime flags without restarting Chromium?
Well, this runtime feature flag, you can toggle. You can't toggle. OK, settings. Screw that. Scratch that. Settings. Web settings. Use it. It's a graduate. I think I can use the things. It always has been a kind of a graduate journey for us. It always started with a compile time, and we couldn't do anything about it. Then it was runtime, and we could do something about it. And we could torture people and convince them converting into a setting, or doing it ourselves, and that it was a setting. So runtime is a good sign for us that the feature can be enabled. Baked in or compiled time is a very bad sign for us. We can go the last mile, but we need you to kind of prepare it and make sure that it works under certain conditions.
What are the version matching rules now? Like if I'm building, say, if I'm running Android, I'm building tip of tree Chromium Android, and I want to debug it from my desktop, when do I know if my desktop Chrome is going to be new enough to allow me to debug my tip of tree Android build?
All right, yeah. So cloud is large. So for every revision of Blink, we will push the front end for this revision into the cloud. And Chrome would actually use it. Now, there are certain interfaces between the front end and the Chrome as a container that could not support some of the new features. So currently, what we do is we show a big warning so that your desktop Chrome is not new enough to be doing remote debugging. We are working on relaxing those constraints and conditions. But theoretically, you can run anything on anything because the front end is actually fetched from the cloud.
So when do you show that warning?
We show that warning on Chrome Inspect when you're attaching a newer device to the older sort of Chrome desktop. I can try showing it to you now.
I think, I mean, I've seen that warning. I've definitely seen it when I'm using, say, beta, trying to debug tip of tree. But I've been surprised that I've been able to use, like, Linux dev channel has seemed to debug my tip of tree Android without giving me that warning. And I keep wondering why. Like, I know my Android code is newer than my Chrome desktop code, and I'm wondering why I'm not getting that warning. And if I should be worried about it. I don't want the warning, so I don't want to have to. There's no Linux canary build, right? I don't want to have to build for Linux every single time I update my Android build.
Right. So, OK, I don't have an old enough Chrome to display that to demo this warning to you.
Is it maybe just keyed off the major version number or something? If the majors match?
I think it is a major match at the moment, and there's a warning. And we were thinking about not preventing you from inspecting, but just warning you that you might hit some unexpected results. So we want you to be able to inspect still.
Okay, thanks.
Yeah. More?
So you mentioned kind of like traceability or actionability is kind of one of the most important aspects of any new instrumentation we add, which I totally understand. I think one of the biggest areas we've suffered, and actually maybe this is kind of relevant to the last talk too about repaint after layout, is being able to backtrack from an invalidation from like okay, this paint event in the inspector, say, or even in tracing, like it's no better, all the way back to this line of user JavaScript manipulated this style that eventually propagated through the rendering pipeline and produced this invalidation. Do we have any hope of being able to trace these things back in the future? I mean, we can't do it now, but
I'm turning it back to the audience because we now have the framework for tracing object identities. It's basically tracing, and we currently use it for layers. So we know how layers bind to nodes. So there's a traceability bit there. There's a handcrafted traceability for all kinds of paint events that trace it back to resources with image names, where we could do that, but there's no generic schema for that. We hope that tracing and object IDs would be a standard one that would be used, and yeah, that's it.
Yeah, I mean, if we can trace the layer to the node, perhaps we could trace the SK picture recording back to JavaScript. I don't know. Well, it's not really to an object, though, right? Like, it's to a line of JavaScript somewhere.
So we're looking to have traceability in scale pictures from particular painting preparation down to nodes that were painted at that time. But if that helps, it's not particularly the level of traceability that you mentioned in your question.
Yeah, there's like halfway.
Right. It's not a line of the code. Right.
Still don't know, like, you know, the web developer still doesn't know, like, well, what did I do that caused this invalidation?
I'm just thinking,
Sure.
there's a lot of moving pieces just to be able to do what you're asking for.
Yeah, no,
because like there's like the invalidation first does a recalc style. Then the recalc style propagates into the render tree into something that will say, oh, we need to repaint, and then we have to generate the repaint. So we would need a way to be able to trace that back to the style recalc. And I'm not sure we have a good way right now to do that. Especially since now with the state machine that we have, this is a kind of asynchronous.
Right.
That is, we can get several style recalc at the same time that generates all at once several invalidations.
So yeah, you kind of want the mapping to be many to one, right? So like, it's possible that multiple style recalcs cause this invalidation, but that could be, you know, that's okay.
So that's something that we already sort of address. When there's a layout thrashing, we would map the forcing layout to one of the invalidations. Not necessarily to all of them, but we start with the first, and as you address your things as a developer, you have a graduate way of resolving the issue over time, which is a good step towards it.
But it seems to me this is an easier problem because you can pinpoint to a single line of code.
Right.
And this line forces basically a synchronous run through the whole state machine. Here we've completely correlated like the change to when we actually do it.
We don't have any false hopes on things being as easy as in synchronous world. But world is asynchronous. That's fine. We deal with it. But tracing is recording enough of identifiers to be able to rewind that and build appropriate mappings. It is going to come at cost, but it would be good in sort of causality and investigating what's actually happening. I mean, we can take it offline and just explore
it. Take it offline, yeah. That's a good. That's an interesting discussion to have.
Okay. More questions? Yeah. Okay.
Do you have like a doc or a getting started guide for someone like web animations to learn how to better make their stuff inspectable?
I was going to show you our documentation. No, it doesn't work. The source code is our documentation. So what aspects of web animation inspectable? So it's a long story. We need to start with identifying what are the use cases. And they're likely to want animations to be debuggable. So we need to trace through source and step through source and see what it results in. So there's a traditional debugging that is already there that would kick things as you step through JavaScript. But then there are some asynchronous processes that you would want to basically track. And as with promises, tracking something that is alive is hard because you don't want to look at the picture that is constantly changing. So you want to have snapshots or recording of things. So depending on the scenarios and on what they want to see, there is going to be sort of debugging approach or instrumenting approach or recording approach. We need to find sort of the way we want to address it and either record the whole thing and then replay it by steps, or see if we can basically stop the asynchronous process and do the traditional stepping debugging there. Latter is harder.
Okay.
First is not as
makes sense. I guess my observation is just like the intuition behind kind of exploding DevTools out into the broader team, as in like every team should be responsible for how their feature looks in DevTools. That makes sense, but my expectation is that many people won't have the expertise that you guys have.
No, I think we don't want to go that far.
Right.
I meant that the instrumentation, in particular on the performance front, and there are things such as trace event is a perfect candidate to be sort of co-owned, so that the expert in the area owns the timing for the area and can raise a flag or add new thing. We are not expecting anyone to have a clue on how to add a feature in the UI, where its place is or how it should be inspected.
So like in the intent to ship, you mentioned like adding debuggability as a field in the intent to ship, but that would be more the team reaching out to you to get you guys to make a change.
Yeah, so the way it works with promises today is we have agreement with V8 team that feature is debugging ready. It means that it has an APIs and hooks that are capable of introspecting the state of promises. And we take it from there. We then work with them on the UIs and on basically working out the workflow and doing things like that. But we want feature to hit stable and be outside of some flag or whatever when it has a full debugging support. Whether we want to enable, whether we want to ship it or not while it is debugging ready but doesn't have a front end, it's an open question. It is up to Op to decide. It probably depends on the feature itself. With promises, I think we want a good debugging support before it hits the user. With web animations, probably also, but then it depends.
Okay, yeah, I think we should look into adding this to the intent to ship.
Yeah. Okay, yeah, good. Okay, no more question? Oh, one more.
Probably the coolest, most useful kind of debugger I've ever used is a time-traveling debugger, like for certain classes of bugs where something happens that mutates some state, and then later on that state causes some corruption or something. On Windows, for example, there's tools that let you do this that like record the exact CPU and memory state at every stage, and it slows. Like the recording can be slow, but for certain classes of bugs, especially state corrupting bugs like that, it's absolutely an amazing tool. Is there any chance has anyone thought about doing something like that for V8 so that JavaScript developers can kind of jump forward and back in time and inspect the state of the heap at various points in time?
V8 is not enough there, right? So there are dozens of projects like that. So there's something happening in WebKit where they record everything, all the input and all the JavaScript execution, and they do the time travel. Oh. They try to, and it's actually behind a flag, but in the source tree of WebKit, as I understand. And there is a lot of tools that are processing the source code, basically. The tracers, whatever, the tools that are parsing source, inserting the tracing points there, logging everything, and then you can basically go back in time and see the whole kind of a path this particular object or property has traveled through time, and see what are the call sites that were mutating it. It is actually possible with a third-party framework. We have an extension API that allows pre-processing JavaScript. So every script that gets into VM gets a chance to be pre-processed using another JavaScript snippet, and then you record things somewhere in a typed array or whatever, and then you can create a front end that would visualize what's happening there. So there are sort of open source projects that are doing it to JavaScript. There are sort of platform capabilities on how to do it on our front. We are looking towards them sort of merging and seeing where it goes.
Awesome, thanks.
Okay. No more questions. Right, thanks.